Right, so I know I'm the last talk. Stick with me for half an hour or 25 minutes if you can. I've got a very grandiose title that I can't possibly do justice to, and a lot of what I'm going to talk about is really about opportunities and challenges, particularly as they lie at the interface between research and government, because I think that's what Martin would have been most interested in. But I do realise there is a whole world of opportunities and challenges that are outside of that space as well. If I don't get your opportunity in, I'm really sorry. If I don't get your challenge in either, it's not intended to be completely comprehensive. The first thing I wanted to just open up with, though, and maybe it's really obvious to all of us, but it's perhaps something that we don't articulate very well when we talk to people, perhaps in government who aren't specialists, or we talk to the public, or we talk to industry, or perhaps even talk to our colleagues in research councils, is just how dynamic and changeable air pollution is as a science problem. Depending on your era, the kind of main problem of the day has changed significantly, and I've just got a few photos. Historically we had real issues around coal combustion and the formation of smog based around sulphur. We had a period perhaps where if you asked what's the most pressing air pollution issue of the day science-wise, it was acid rain and the transboundary export of pollution. We've lived through a period when probably road transport has been the key issue of the day, and we're going to be going into a period where there are going to be new problems. I think we need to always step back and explain this to people to say, why are we all still here doing research on a problem that's existed for hundreds, if not thousands of years? And it's the dynamic nature of the problem is the reason you keep needing to do research on air pollution. We need to fix problems that are going to crop up in the future, not just look backwards at the things we've done before. So my last picture on this one of four is not the only thing that's going to affect air quality in the future, but it looms large over almost everything, which is the massive rewiring of society to decarbonise. And air quality is potentially a benefit of that, but it's also potentially collateral damage as well. And it would be really nice if we as a community were stopping problems before they emerged, rather than the way we've worked historically, which is fixing problems after they've become apparent. Slightly overused plot that I probably show on almost every slide, but there's quite a lot of good news associated with how we've managed air pollution, how we've used science to do that. And this is from a Royal Society report from a couple of years ago, and it's the trajectory of emissions, which is the slightly more flattering way to look at the problem. But we have seen hugely steep declines in emissions over a 50, 60-year period. And we maybe ought to make a bit more of this than we do, if only to motivate decision makers that if you support air pollution science and you bring it into policy and you introduce interventions, we can generate changes pretty quickly, far more quickly than perhaps can be generated in the greenhouse gas reduction world. So the rate of reduction of some pollutants is really very dramatic. Now these are totals for individual pollutants, and I'll get into just one sector in the next slide, but the rate of change is incredibly fast. So we have to keep that in mind. Effective interventions that we advocate for today may not necessarily be very effective interventions in 10 years' time, because the world would have shifted around us. And that kind of education piece, keeping ourselves all up to date with what is the problem of today, and keeping everybody else up to speed on that around communication and talking to the public, is also important. And it makes it doubly difficult when the stories that we tell today around the causes of pollution that affect people will probably be different stories to the ones that we'll be telling in 10 years' time. But one thing before I leave this slide, and it's not been talked about that much, and maybe this is my bias as a physical scientist, in the end, the thing that makes air quality better is reducing emissions. We can communicate the problem, we can talk about where the pollution is, we can put in monitoring, we can show pollution. If we want to make it better, the only tool we have is to reduce emissions. And almost everything that's driven those reductions in the graph there over the last 70 years are rather gnarly, detailed, technical abatements that have been brought in. So we can't lose sight of that. And there hasn't been an awful lot of talk about abatement and emissions reduction in this meeting. But if we actually want to make pollution lower for people, we will have to lower emissions. And we have to be clear who in our community is providing that science advice. So it's basic science that has to be done. I also have a slight side gig with the Department for Transport, And transport is one of those sectors where the changes, or the rate of change, is incredibly fast. Transport has clearly been, historically, an enormous source of problem pollutants in cities, certainly from about 1990 through to perhaps 2015. But there's two graphs here that show the rate of change in emissions of two pollutants, NOx from three classes of road transport, and then primary particulate emissions. And you can see over a relatively short space of time, so I sort of started my research career in 1992, so more or less at the start of the graph on NOx, the reduction in emissions is really quite dramatic. It isn't saying it's a problem solved, but interventions, for example, clean air zones that were brought in perhaps halfway through that period, were dealing with a world of emissions that looks rather different to today. And you project forward not so far into the future, and the vast majority of those emissions have begun to disappear. So I think this is a really good example around making sure that we are absolutely up to date with what problem are we dealing with today and in the next 5 years, not are we still dealing with the problem as it was 5 or 10 years ago. And again, there have been equally steep reductions in tailpipe emissions of particulates as well, really very large quantities emitted only perhaps 15 or 20 years ago, very, very low amounts today, essentially dwindling away to nothing as a lot of the road transport fleet electrifies. And just coming back to my previous point, why have they reduced? They've reduced because of technological interventions that managed emissions in combinations with regulations that required it. And this is something I'm going to pick up on a little bit later. A lot of talk at this conference has been about the interface between science and policy, which is really crucial. But I'm going to talk a little bit about the interface between science and the law, which is slightly different as a driver of change. But I think you can pick up these sorts of things in all sorts of sectors, and they are dramatic. And I think when we talk to people outside of our community and we want to motivate them that it's worth taking action, pointing at some of the things and the rates of change from the past, I think is quite helpful. You can see changes that are worthwhile within political lifetimes, which is, I think, quite important. Again, I'm referring back to a Royal Society report from a couple of years ago, but clearly one of the big opportunities that we've got is around decarbonisation. And this Royal Society report tried to look at what the air quality impacts would be across the delivery of net zero. And broadly speaking, on this sort of schematic, pretty much everything with net zero, you can argue, will be beneficial for air quality. There are some emissions, of course, that are not captured by decarbonisation. So, for example, some emissions inside the home from chemical products, they're completely independent to decarbonisation. But broadly speaking, most of the actions are positive, going to improve air quality. But for quite a lot of these sectors, the band looks quite broad. Is it a big benefit for air quality, or is it only marginal? And the width of those bands, at the time this report was written, and I still think it's the case, is we don't quite know which fork in the road we're going to take for decarbonisation. There are still a lot of decisions to be made. The one that perhaps we're most familiar with is we probably have made the decision that passenger cars will be battery electric. That is probably a fork where we've taken the decision and we're going down that route. But there's a surprising number of decarbonisation options where we're still only in the foothills, and it isn't clear which technology is the right one to take, and the one that we choose has a different air quality outcome depending on the pathway. And this is where we really do need to be actively engaged to make sure that when the decisions around decarbonisation pathways are made, we are banging the drum to say that have you considered the air quality and the public health impacts as well. And so there are kind of two key messages. This was a report led by David Fowler, and he spent a lot of time writing a lot of words, but I'll summarise it. Basically, try not to burn stuff to get to net zero. If you must burn stuff, make sure it's a lot better than the current fuel or the current technology. So we shouldn't necessarily be anti-burning things, but if we do burn things, we should do a lot better than we do today. So I'm just going to pick up on a couple of strands of this. I'm sorry, there's no time to talk about all of them. But one area that I'm really enthusiastic that we are out talking about is around ensuring that there is clean net zero combustion. I think perhaps 5 years ago, most of us, or maybe 10 years ago, had a kind of utopian view. And actually it's included in some IPCC assessments of emissions that almost the world would be entirely electrified and use batteries. And I think we now know reality isn't going to look like that, we are going to end up burning things, but ideally things that have lower greenhouse gas impact than the fuels that we used before derived from fossil fuels. And there are three sectors that I've got here, and you may have other sectors that you think are not going to be able to transfer entirely to electrification, but here are three where I think people are pretty convinced that we're going to have to keep burning stuff in the future, even under a net zero world. One is international maritime, one is the off-road sector, and the third is medium and long-haul aviation. And we can already see, because road transport and other emissions are falling, we can already begin to feel the impact of some of these rather niche sectors that are probably not high on the public's agenda as being contributors to air quality. I think this is quite a fascinating map of where NOx emissions have got to now. I think this is 2022. 10 years ago, you would never have been able to see the airports and the runways because emissions from road transport were so high. As road transport's diminished, you don't have any problem spotting where 4 airports are around central London. If you propagate forward another 10 years, the road networks begin to disappear and all that's left is a black hole in the middle, ringed by 4 rather long sources of NOx. And it seems pretty unlikely that there's going to be any other alternative but burning things for that. So that's one sector. So if we're going to burn fuels that are carbon neutral or closer to carbon neutral, how to ensure we don't end up with air pollution hotspots around those airports? Similarly, maritime is going to be very hard to electrify, certainly for large and long distance. You might say, well, it's a relatively small source, but in a world where we've perhaps dealt with domestic combustion and road transport, certainly in the south and east of England, several parts per billion of your nitrogen dioxide will come from shipping from the Channel. And in the context of a WHO guideline of only 10 micrograms, quite a big fraction of that will come from ships. So if we're going to fuel ships with alternative fuels, can we do better and get lower emissions than we get today? And the final one is the construction sector, which is beginning to converge on hydrogen combustion potentially as a fuel for the future. And that sector, because it's quite heavily permitted, is rather aware of air quality as an impact. And their proposal is to try to generate very low emissions through using lean burn hydrogen combustion. So in each of these cases, if we're going to transition to a new fuel to decarbonise, can we get a real step change in reducing air quality emissions at the same time? And that will need people in this room to be advocating for that. It's not just about reducing CO2, but we must demand that we can get some reductions in other pollutants as well. But, and I guess the kind of theme for my sort of second half here is that we have for a long time used this approach that we tackle entire sectors with sort of regulation from central government. And we kind of hope that that will just bring improvements to everybody. It's this idea of a sort of rising tide lifts all boats. So if we have better emissions controls on all cars, hopefully everybody will benefit from all cars. Well, a lot of the easy wins have all been done now. And so we're perhaps left in a world that we can't quite use the same approaches to reducing emissions that we could before. And we perhaps need to look a little bit more and be more targeted. And this is where there is another AQEG report, which I hope you'll be able to read quite soon, looking at the disparities in air pollution across the UK. We have very uneven distribution in pollution. This has been raised multiple times through the last 2 days. Sometimes that's just purely a function of geography and weather. Sometimes you get good weather or favourable weather for air quality in the UK because you live in the wet and windy northwest. Sometimes you get poor air quality in your area because there are a lot of emissions that have been located there, which is a different sort of disparity. And so we have looked at this on AQEG, and there's actually only a loose association really between the concentrations of a pollutant that you experience and the emissions in your neighbourhood. But taken at the national level, a lot of that is skewed by the fact that we have a big southeast to northwest gradient in air pollution concentrations driven partly by transboundary effects. When you dig into the detail and you look at different communities of who is affected, and you look specifically at the emissions, which are the choices we as a society have made around where do we put our emissions, that's the thing that we do have under our control. We don't have weather under our control, but we do have a choice around where emissions go. We then find that those in the most deprived groups, this has been raised before, receive far more emissions in their neighbourhoods than those who are the least deprived. So this is indices of multiple deprivation. Number 1 means you're the most deprived. Number 10 means you're the least deprived. And looking across the UK as a whole at the LSOA level, you're probably going to get twice as much NOx on average emitted in your neighbourhood if you're in the most deprived groups to if you're in the least deprived. There's sometimes a thought that this is all driven by traffic, but actually it isn't. If you disaggregate the black line into the contributory causes, some of that disparity in emissions is driven by traffic. There is often more traffic in more deprived neighbourhoods, but it's also driven by domestic combustion. There are simply more houses per square kilometre. There's more construction per square kilometre. There's more industry per square kilometre. So disparities in certainly where the emissions are located, and it's a similar picture for primary PM2.5. It is no longer solely a traffic problem. It comes from many different sources, and we will need to perhaps be more targeted at addressing this rather than trying to change the entire emissions landscape across the UK. This is some work from Sarah Moller and Nathan Gray at York. And if you dig further and you start to look at the effects and you strip out the effect of deprivation, there is this well-reported link between deprivation and emissions in your neighbourhood, and that's represented by the blue line on here between IMD, my glasses on, I think 3 and 6. You would follow the blue line. But if we look at the latest UK census data, what we actually find is that virtually every minoritised community lives above that line. So that basically means that if you are in those communities, you receive more air pollution emissions in your neighbourhood than a deprivation-matched majority white community. And that really runs almost entirely across the board, including for minority groups that actually have quite high levels of affluence. So there's an awful lot to dig at here, and we have a lot of issues around where emissions are located and why they're located there, and why people are co-located with them. It's not always we put emissions in a particular place. Sometimes people have moved to where emissions are because housing is cheaper. But I think in the future we are going to have to get to grips with this as perhaps the next big frontier in developing policy. To finish off, I'm going to talk about air quality standards and the law, and I've gone on a steep learning curve with 2 people, Eloise Scotford and Delphine Misson, who are both environmental lawyers, one at UCL and one at UC Louvain in Brussels. And we recently wrote a paper on how the law is a significant driver for policy, and how we might get more science into law rather than necessarily science into policy. And the general thesis for this is that actually it's the law that drives policy responses. Those in government can perhaps correct me if I'm wrong, but the number 1 requirement is to comply with the law. And if the law says you have to do things, that will shape your policy response. So whilst we might have lots of great ideas about how to improve air quality, if it's a legal requirement to do it, it will come to the top of the pile. So what does that mean? Well, this gets us into the world of what do air quality regimes and what does air quality governance look like. And we talk a lot about one of the orange bits of that circle, which is what should the objectives be. I'm not quite sure how many times limit values have been mentioned, but it must be dozens of times in dozens of talks. We talk a lot about what the objective should be. We don't talk quite as much about some of the other parts of the segments here. Simply setting a limit value is absolutely no good if you don't have a good monitoring system, if you don't have access to justice, if you don't have a process for revising the guidelines. And perhaps sometimes we're a little bit laser focused on producing a number or a recommendation without thinking about how science can guide some of the other parts of the wheel here. And there's a lot of role for science in a lot of these areas, and we perhaps underplay that with our focus on what's the right limit value. And there's been 2 reports by UNEP, one which was a review of legislation globally, and many countries still have no air quality legal regimes. And the second one that I was involved with was a guide for future legal requirements. But I say there is an awful lot more to this than picking a number, and I think perhaps we could do a lot by getting our science to inform some of these other areas as well. And access to information, which actually follows one of Dave's points, is a really critical part of that. The ability to challenge is often limited by your access to information, which is one of the wheels. Limit values have been obviously a very powerful, simple to understand tool. They have worked very effectively in lots of countries, particularly when air quality is bad. They're a very simple legal tool in the sense that most people can understand what they do, and they do try change. But of course, as air quality improves, the number of red dots that sit above a limit value diminishes, and rather than necessarily tackling air pollution in the whole, there is perhaps a temptation to tackle just the handful of red dots that remains. Until such point as there are no more red dots, and one might argue that the job is done, whereas of course the evidence suggests that even the dots below the line are still significant. So we do have to have a think about the fitness for purpose of limit values into the future, and how, if we want to retain them, and I'm certainly not arguing against scrapping them, how will we go about setting them, and what is the right sort of value that we might want to do, and how will science play into that process? Because if we focus on small numbers of locations, the benefit doesn't necessarily help the population as a whole. It may be only a small number. So this is where I think there's some interesting stuff for us to have a discussion amongst a kind of wide range of different stakeholders in all of this, which is, what do we begin to do when the feasibility of laws begins to diverge somewhat from some of the scientific evidence, firstly on harms, and what might be done. So we have this guide from WHO, recently updated, suggesting very low concentrations would be desirable for our air quality. There's probably no lower limit to the effect of harms from air pollution. That would suggest that actually a limit value of 0 might be the ultimate objective. But we can't live in a zero pollution world, or not one that's worth living in. So how will we find a scientifically informed pathway through this that will be both sort of acceptable to us as an optimisation, often as a group of scientists, but will also be acceptable to sort of civil society as a whole, and will be deliverable by politicians as well, which is equally important. And if we do have health-based guidelines, and I can only assume we're going to get more and more health-based guidelines because there's a huge community working on things like this, and the idea of a sort of limit is now quite well entrenched. I think one of the things that has to come right at the top of the list when setting laws is it feasible? Because a law can only be set if you have some reasonable chance of complying with it. So we come in with the scientific community right at the start of this, which is to ask the question, is this target that we might set, or an objective, or a guideline, or whatever we choose as our sort of language for this, can we do it? Is there some pathway technologically to reach the concentrations that we would like to? And if the answer is yes, then we can move on to the next question, which is this socially or politically or economically feasible? If the answer to that is yes as well, then we probably end up where we ended up with the Environment Act in 2021. It was demonstrated that the 10 micrograms PM2.5 value was likely feasible at some point in the future. That aligned with the scientific evidence. It aligned with the political view that it was socially and politically and economically acceptable, and that's what was passed into law. Some argument about the date that you reach it, but a relatively straightforward kind of decision tree. If the decision had been no, we would at least want to have clarity that that was a political or an economic decision, not a scientific one. But in a way, I suspect we've done the easy one, because at that point the values were ones where it wasn't so contentious about whether you could reach a guideline. We're now probably in a world where quite often, for a lot of countries, not all, and possibly not for some parts of the UK, what do we do if it's not scientifically feasible? What if we can't run a model scenario that can reach 5 micrograms per cubic metre of PM2.5, or 10 micrograms per cubic metre of NO2? What do we do then? Well, I've got 3 options, but I'm sure you can think of more of them. One of them is to say, well, ignore it. Basically, we put it into law, and we have a position where a government is in perpetual breach of that law. We follow the medical guidelines to the letter, we put that into law, and we accept that there will be a perpetual breach of that standard. There is, of course, a risk there that everybody ignores it, because no matter what you do, you can't win. There are other options, but that is one option, is to simply say, well, we take the health guidelines as read. Another option is to say, is there a fudge? Is there a workaround that allows us to sort of say, yes, it is feasible. And this one, it's too small to see. But this is kind of what the US have just done with their new guideline, their new objective of 9 micrograms, which is to say, well, we get to subtract off uncontrollable pollution, particularly wildfires in the US. And so we grant executive discretion to somebody to make the call about what is subtractable pollution and what isn't. And when we put that caveat in, then actually, yes, it becomes scientifically feasible. So that's another option that we could take. We could subtract off events that we feel are beyond government's control. I think the US one even allows them to subtract off industrial accidents as well, which is maybe on the margins. But that's one possible route back to obtaining feasibility, with pros and cons that we might all have different views on. But that is another option. The third is to begin to diverge, and this is perhaps the Canadian model, which is to look at feasibility and pick a value that you feel is feasible, but with the caveat that you need to keep rechecking that feasibility regularly in order that you don't become complacent. And I think the Canadian value is a very strange number, like 8.8 micrograms per cubic metre, but is under almost continual revision. So we've got a lot of options, but I don't think perhaps we as a science community engaging with other people have talked an awful lot about this, because we can run scenarios and we can see how each of these might play out. And I think this is an area where this intersection between science and law is actually really quite significant in terms of providing guidance about where would we like to go next beyond the air quality standards that we've got now. Just finally, we have to reflect that the UK, particularly in the southeast, has some very specific challenges around transboundary emissions. You can cut it in various different ways, but in 2030, the amount of pollution that would be under control of a metro mayor is quite small. A lot of the chunk is built up from regional and transboundary pollution. So how will we handle that in the setting of targets? Or indeed, the actual non-trivial contribution from natural PM as well, which could be 1 or 2 micrograms. So, we have to face up to this challenge, and it's obviously particularly relevant in the southeast. And there are these alternative objectives that we could set myself, and I'm not going to spend very much time on these because you can dream up lots of them, but we need to begin to quantify the benefits of these and how we might reach them. We have a population exposure reduction target that aims to essentially make sure that all, or the average of all locations population weighted drags the mean value for a particular pollutant, PM2.5, down, or at least it stops regression. You could think of other targets around reducing disparity as being one of the objectives, or perhaps taking things in from the US which are around environmental justice as well. And kind of my final point, and this is just the last couple of slides, is maybe we also as a community have to think a little bit more about other metrics. PM2.5, as anyone who measures PM knows, is a nightmare. You'd never have chosen it now. And I think anybody who produces instruments that measure PM2.5 probably wouldn't have that much confidence in measuring 3 or 4 micrograms with it. And we have gone through this transition before. When I started doing air pollution, it was all about PM10, and that was slowly phased out in favour of PM2.5. So we have undergone these transitions before where we thought we'd be better off with a different metric that was possibly more specific to harms and was maybe more tractable for policymakers to work on as an objective. And if you're an aerosol person, pick your favourite one: black carbon, ultrafine particles, SOA, metals. That's an open debate. But it isn't such a big stretch to think about moving to alternative metrics, because we have already kind of done that from PM10 to PM2.5. And this is kind of my final science side, and I'm a measurement person at heart, so I couldn't kind of finish without putting something on the need for measurements. And there is a real issue around how do you build the evidence base around alternative measures of pollution, or alternative metrics that you might want to control. And one of those is that unless you've got observations, it's very hard to do epidemiological studies. But we don't tend to monitor things long term for epidemiological studies until there's a legal mandate to do it. And then you end up with this chicken and egg situation that you need the measurement, but you don't have the mandate to make the measurement. And I think one of the things that we may need to think about for the future is kind of injecting into this a legal obligation for precautionary monitoring in order to ensure that we are going to collect sort of future-proofed data that will allow epidemiological evidence to emerge, that will allow us to develop new standards. And I do think we're a little bit locked at the moment into a kind of closed loop around data. So my summary, there has been huge progress on emissions, and it is actually a testament to government interventions and technological interventions and so on that's made that happen. But dealing things sector-wide now is diminishing returns. We've got no more coal-fired power stations to close. That's one example. There's going to be a lot more to decarbonisation than batteries, so we need to be right at the forefront of arguing that we are central to the energy transition, making sure we do it as cleanly as possible. We have to begin to address the disparities that exist where remaining emissions occur. We have to grasp that nettle and provide good advice on how we can target work and interventions in the most effective places. It's legal standards that make government act. It's trips to the High Court that sharpen the mind, not a great paper that I wrote in ES&T. So we need to be really engaging with legal standards a lot more if we want them to be the driver of policy responses, and that's an area where we've been more limited. We do need to open the debate around how we reflect and get new air quality standards in that are going to be pragmatic and deliverable, that are going to get us the health benefits that we want, but that are also going to be politically deliverable as well. And that's a kind of open conversation I think that we've got to have, because there are no easy answers on this. And I do think there is this need for kind of a precautionary monitoring of non-regulated pollutants in order to beef up the evidence base that we've got, but potentially at some point a transition to the monitoring and the regulation of other pollutants other than PM2.5. So thank you very much.